Files are organized this way. Okay. What kind of structure is this? What? What is this? What kind of organization is this? What kind of tree is this? Yeah, it's actually search tree and 2-3 tree, maybe 3 tree, ternary tree. But it's a search tree. It's not binary search tree, but it's a ternary search tree. And the file structures, I mean those 4-tree trees and the B trees and B plus trees. Remember all those three types? They were all implemented on the disks, and they are very useful for searching something very fast in logarithmic time. And there are three types of file structures. Okay, remember we are talking about the file structures. Okay, let's look at some of the file types. Okay, what kind of file types we have? We have the regular files. It's not regular, it's regular. And special files. For this chapter, we will be looking at these regular files most of the time. But there are, for some systems, there are special files. What kind of special files are these? Like the well, the swap files are not directly accessible to the user of the operating system, but they can be considered as a special file. But for the Windows environment, the swap file is a regular file actually. It is not a special file. We are talking about on Unix systems. Most of I/O devices have file names. Remember the dev directory? Okay. When you have this device directory, and under the device directory we have HD1 and HD2 and that kind of stuff. These are the files, right? But these are in fact not regular files. These files are connected to these files are connected to some kind of a hardware, either a hard drive or your mouse, or under this device directory there are many files, and each file is connected to a device. They are not regular files. One of them, some of the devices are hard drives, some of them are floppy drives, some of them are your keyboards, okay, and your mouse, and your screen. Each of these files under this dev directory is a special file, and they have name, but they are I/O devices. Okay. Directories are special files. Directories are files. Okay. They are special files. They hold the names of other files, which could be directories or some other regular files. Okay. Some communication channels have file names. Okay. A communication channel has a file name. If you use that communication channel name to open a file, then you are writing to that communication file, or you are reading from that communication file. So when you provide this file abstraction, okay, when you provide this file abstraction to the user, using that abstraction, the user can read or write from the files, read from the files, write to the files, or read and write to and from the I/O devices using the same file abstraction. The user doesn't know if it is writing to a file or if it is sending data to a communication channel. These are all the advantages of abstracting the files in your operating system. Okay, any questions? Okay, in your regular files, when you open a file, it has some kind of structure in it, and it depends on the type of the file, what kind of structure we have. For example, for this one, it's a Unix executable file. This is the structure of the file itself. When you open an executable file, okay, a compiled code, at the beginning we have the magic number. Why do we use this magic number? Magic number is a special number, okay? Let's say it is 0xABF2B, okay? The operating system, when you say that execute this file, operating system immediately opens this file and looks at this magic number to see if it is this number. Okay, if it is not that number, that say that this file is not an executable file. So somebody renamed it by mistake to make it an execute file, or somebody changed its mode to set the execute mode. So this is just a simple check if it's a real a magic file, executable file or not. Then we have the text size. What is text size? Size of the executable code. Okay, because this is an executable file. And we have the data size. Okay, and we have our stack size. So our symbol table size, and this is our entry point. What is entry point? Entry point is where the program should execute, where the program should start the execution. This is called entry point. So by looking at all these size numbers, the operating system immediately knows how much memory should allocate initially for this executable program. Okay? So it knows it. Then we have various flags. Then we have our text section, data section, and some other details about executable files. So this is just one structure of a file, a sample file type, executable file, and it depends on the operating system. It is not the same, exactly the same for all types of operating system. It is different for different types of operating system. In fact, within a single operating system, you might have different types of executable files. Okay, for example, for the MSS environment, we used to have these .com executable files and .exe executable files. These were very, very fast and small, but their address spaces were very small. You couldn't write very large programs with this type of formats. For this one, these could be large, but they are slow to load and execute. Okay, so even within a single operating system, you might have different types of executable files. Another one, archive, an archive file from a Unix operating system again. In the header, I have the archive model name, the date and the order and the protection and the size, and these are the archives, whatever you are trying to archive. So two very simple file types, and we have access modes for each file. You know what sequential access is. For the sequential access, you could read all the bytes, okay, or records in an order. You start from the beginning and you go one by one. Very easy to read these files, but no skipping around. You cannot say skip 5 forward or come back 10 records before. You can't say that kind of stuff for sequential accesses. For that case, we have random access files. In random access files, you can go to any record or any byte you like to access, and operating system gives you these types of flexible interfaces for these type of files. Okay. Then we have the attributes for the files. We have each file have a name. Okay, it should have a name and it contains data. We know that. But other than those, we have information about the file. It's called file attributes. Those are the dates and the time the file was last modified and when it was created, etc. Okay, these are all called attributes, and some people call these metadata. Okay, metadata. Attributes and metadata are the same thing, and these attributes are different for different operating systems. And in fact, it becomes a problem when you copy a file from Unix operating system to the Windows operating system, because the ownership and the permissions of Unix environment is different from the Windows environment. So what do you do when you copy a file from Unix to the Windows? What do you do with the execution bed for the owner and the group and the others group, right? And because in the Windows environment, we don't have the group execution bit. We don't have the others execution bit. So what do you do with those type of stuff? Is not known. So these become some problem. What I'm saying is that these attributes are very different from operating system to operating system, and it becomes a problem to move from a file from one operating system to the other operating system. Okay, here are some possible file attributes. Some operating systems support these all the time. Some of them they don't support them at all. For example, for some systems you can define passwords for each file. A different password for each file. If you don't have the password, you cannot open that file. And we have these kind of passwords for the zip files in Windows environment and the other environments. And we have the protection attributes. And these protection attributes exist for all types of operating systems, but they are different. The creator ID of the file, the owner, usually these two are the same for most of the operating system, but some operating systems are, this creator and owner, but some operating systems, they can define it differently. Read-only flag, can I read and write, or read-only? Hidden flag, okay. If it is one, then it's a hidden file. You cannot, when it is hidden, usually you don't see it when the file is listed. Okay. And if it's a system file or a regular file, okay, so it can be changed. For the Windows environment, there is a flag to set it if it says Windows, if it's a system file or not. For Unix, we don't have. For Unix, we don't have such bits. And then we have archive flag. If it's a backed-up file or a regular file. If it's an ASCII file or the binary file. Some operating systems have these and some of them, they don't have it. Okay. For example, in Unix, we don't have this bit. Okay. Random access flag. Again, we don't have this bit in Unix. Temporary flag is important. If it is one, okay, that means that some process has used it to do some temporary job. When that process exits, when that process finishes, you need to delete this file. Okay. Locks flag. If it's a locked file or not locked file, this flag could be used for synchronization between the processes. And the record length, number of bytes in a record. If it's a record-based file, we don't have this in Unix environment. The key position, offset of the key within each record. Remember the tree-based file structure? So in the tree-based file structure, for each record you have your key, and you need to specify where that key is within the record. So this is the key position. Key length, again, how long is my key? I need to know that if I am using a structured file. Creation file, time of last access, time of last change, the current size and the maximum size. Some operating system asks you to give the maximum size for that type of file, and you can specify this. So these are some attributes, and some people call this metadata. Okay, so let's look at some file operations that, remember, we are trying to abstract the file system. How do I abstract it? We define some operations for the user to use them, right? So these are the operations that a user can perform on files and file systems. A user can create a file, can delete a file if he or she has enough permissions, open a file, close a file, read from the file and write to a file, or you can append it. We all know that, okay, we all know the C functions that call these system utility, system calls from our C programming classes. We create, how do you create a file using a C function? How do you create it? You just open it with a special flag, right? You open a file and you say that if you have that flag, if the file is not there, then create it. Okay? I don't think that you have seen this delete, but is it possible to delete? Is there a function called named delete? I don't remember. Remove C function. I don't remember. There should be one, okay? And we know all of these, right? We know all of these. Opening and creating it is done at the same time. Reading and writing it. Appending is done using the open again. C, we have a function for that, right? Get attributes and set attributes and rename. These are all defined by the operating systems, and you have the interfaces for these system calls. You call your functions. You call your functions that call these system services, and you get all of your operations performed on a file. It doesn't matter if the file is stored on a disk or on a SSD device or on a network drive or on a Dropbox file. It doesn't matter for you. All you do is you just open and close. The rest of the complexities are handled by the operating system, which might be very, very complex. You don't know if your file system is using a byte-based file system or record-based file system or some other structure. Okay, here we have a small program, C program, that uses some of these file system calls. If I can find it, no, I couldn't find it. I didn't copy it here, sorry. But I will find it where? I will find it somewhere. Where did I put it? Maybe here? No. Okay, let's read it from the book then. Okay, the book has it. So, okay. $274. Okay. Okay. A small program for copying files from the source to destination. Okay, from source to destination. R includes, okay, necessary other files. I don't know what is STD. Okay, we will skip those. So it's our main. We are going to use command line arguments. Okay, buffer size and output mode. That means our output mode is 00700. That means that read write execute for the user, and 00 for the group and others. Okay, so only the user can read write and execute. Okay, so our handles for the, these are handles for the input file and output file, and this is our buffer of characters. If I don't have 3 arguments, then I will report an error message, and immediately I cannot. Okay, I would exit immediately if I don't have enough number of files, enough number of arguments. So my program will work like this. Let's say my program name is copy. It will be should open the other. What was the page number?
270.
306. Okay. So if I don't have, let's say my program is named copy source and destination. So this will be the format. If I don't have 3 arguments, then I will exit. Then I read the first argument, okay? First argument. Open a file, open read only. And where is it? Open read only is defined, and I guess in this header, right? Is that correct? I don't know where it's defined. It is defined somewhere in one of those header files. Then if I cannot open it, remember this one. If it is smaller than, if it returns a negative number, then it's an error. Then I will say that it's an error. I will exit. This is 1, this is 2, and this is 3. So it is producing a different signal for different type of error messages. If it cannot open the source file, then it will exit. If it cannot open the second file, this function, I don't think that you used this before. Okay, create, and it will produce another error signal. And in the output mode, it will be opened. And output mode is here. Okay. And then in a loop, I will read buffer size, okay, using this function read from the input file to the buffer, okay. If I cannot read enough number of bytes, okay, if the read count is less than or equal to 0, then I would break.